Okay, this is still 2.5, part 3. Here's what I was talking about as far as kind of building up to be able to write your own two-column proof. So in this example, I have a given. Here's what we're trying to prove. There's a diagram. It's a basic format of your two-column proof. Some statements, actually all the statements are already given to me, and I have to fill in 3 out of the 4 reasons just to try to figure out the logical order that things need to go in, and then just figuring out like how your two-column proofs are set up. But going back to the given, here's what we're given. AC, the length of this entire segment, is equal to the length of AB, because there's no little segment symbol above that. That means the length of AB plus the length of AB. And we're trying to prove that the length of AB is equal to the length of BC. All right. So here's what was given. That's our first statement. First statement should always be what's given, which means the first reason should be what's given. Then if I look at the second statement, you probably need to refer back to the diagram at the same time as well. I might need to look back at the previous statement as well to figure out the reason. But looking at the diagram, the length of AB, this part right here, plus the length of BC is equal to the length of AC. For each part, here's what I'm going to suggest. Like, you think about it on your own. You possibly pause the video right now and try to figure out what reason you're going to give before we go over it together. Once you figure out the reason that you need, here's where you're going to have to remember kind of everything so far that we've gone over in geometry. That's probably one of the things that makes your proof so hard, especially once we get into proofs with triangles and so on, which will be, sorry, I don't remember the exact chapter, but then you're going to have to remember everything previous to that. If it's chapter 5, then you have to remember chapters 4, 3, 2, and 1. Okay, but what says the length of this part of the segment plus the length of this part of the segment equals the length of the whole segment is the segment addition postulate. Remember, the sum of the parts of the segment is equal to the whole part. Okay. And then for the next statement, the length of AB plus the length of AB equals the length of AB plus the length of BC. Okay, that's kind of a mouthful. And then if you look at the diagram, maybe you look at the diagram and think, well, shoot, I have no idea what the reason should be. Then I look at the previous statement, AB plus BC equals AC. Notice that's right here. So maybe just looking at the previous statement isn't good enough. Then I look at the statement before that. Length of AB plus the length of AB equals the length of AC. Okay. This part right here is right here. So here I really have to look at statements 1 and 2 to be able to figure out the reason for statement 3. Okay. And then if you figured it out, in this case, I would accept, or it's acceptable that you write 2 different reasons. One of the reasons that you can give is substitution, because for the length of AC, since the length of AC is equal to the length of AB plus the length of AB, if you substitute AB plus AB in here, then you get AB plus AB equals AB plus BC. So substitution could be correct. Substitution, I spelled that wrong. Let me go back and erase it. But that's the reason for statement number 3, substitution. The other reason that you can give is the transitive property. You can think about it like this. If A equals B, and then A equals C, okay, then B equals C. So I would accept, or you could also write the transitive property. Okay, and then the last statement, AB is equal to BC. Think about that. Maybe again, pause the video. So if you thought about why you can make that next statement, AB is equal to BC, basically what you're trying to prove, not basically, it is what you're trying to prove, but notice you have AB here on the left side, that's right here. You have BC on the right side here, and then you have the exact same thing that you're adding to A, B, and B, C. So you basically want to get rid of that. And I know it doesn't show it, but you can subtract AB from the left side. You could subtract AB from the right side. So reason number 4 should be the subtraction property or subtraction property of equality, because you're subtracting AB or the length of AB from each side of the equation. Here's where you have to know the properties and then possibly other postulates or definitions like we did on the last example of a proof. But subtraction property of equality for the last reason. And that completes that 2-column proof.